Okay, welcome to our project here that we're going to be working on sea ice climatology. So I'm just going to start our little coding window up here that we have on the upper left with a note, and that's how we denote a note with a little hashtag. You only need one. That we're just going to call this our sea ice climatology exercise. So in this exercise, we'll be writing code up in this upper left panel, and then we'll be executing our commands down here in our console. You can see I'm running R version 4.2. Up here you'll see when we actually have objects or environments that are created, and then over here will be our plots and our files and our package helps and things like that. So one of the things that we're going to be doing is using the National Snow and Ice Data Center, that's nsidc.org, to read in sea ice data. And so that's going to be something that we code in here. We're actually going to be using an FTP site, which stands for File Transfer Protocol. And I'll just show you this site here right now. This is the National Snow and Ice Data Center. They have all kinds of different snow and ice data that you guys can use, and this data is generated by NASA, NOAA, and the National Science Foundation. We're going to be focusing mostly on sea ice here. So if you click on sea ice, you'll see that one of our first things that comes up, which is our sea ice index. This particular product is actually generated by NOAA, so I'm going to click on that. And we're going to be using Sea Ice Index version 3, and this gives you a little rundown of what this Sea Ice Index. It provides a quick look at the Arctic and Antarctic-wide changes in sea ice. It's a source of consistent, up-to-date sea ice extent and concentration, both images and data, and they go from 1978 to present. So you can come down here and see what the parameters are, what the spatial coverage is, what the spatial resolution is. So this is 25 by 25 kilometer. Here's just a little picture of the spatial coverage that they have. And the data comes in as a PNG, which is an image, a geotiff, which is an image, a shapefile, which is like a GIS file. We're going to be using CSV files, which stand for comma separated values. And we'll be looking at data from 1978 to present, and the temporal resolution is in fact 1 day. Now to download some of this data, we're going to click on Download Data, and you can do a couple different things. You can either subscribe to stay informed, which is kind of interesting. You don't have to do it, or you can go to the FTP site, which is right here. Now it says here, and this is really important, that most new versions of web browsers like Chrome, Firefox, Edge, and Safari now block FTP addresses. And so we can recommend trying to access FTP using FTP client and the command line and a Python script. And there's a tutorial here for doing that. But we're going to go ahead and use Chrome anyway. And so the way that you do this in Chrome is you go to a site called chrome://flags. And this is going to bring up some of the flags or blocks that Chrome's use. And we can reverse these right after this exercise. But if you just type in FTP, you're going to enable support for FTP URLs, which is like a website. So when enabled, this browser will handle navigations to FTP by showing a directory listing or downloading resources over FTP. When disabled, the browser has no special handling. It just won't open it. So we're just going to set this to enabled. We're going to do that, and then what you're going to have to do is relaunch Chrome right here. So I'm going to relaunch it. And now we have this enabled, and we can come back to this and disable it again when we're finished. So we'll go back to National Snow and Ice Data Set here, and if you go now to FTP, it will bring you to this FTP site. Again, it's showing you it's not secure because it breaches some of the security standards for Chrome, but we're just going to use it briefly. This is like a file directory on another computer that's hosted at Colorado, University of Colorado. And there's a little README here that you can take a look at. If you open it here, this tells you, here's the documentation. You want to read all this stuff. Here's Sea Ice Index. If you have any questions, you can read that. But then there's also a north and a south. So let's go ahead and click on north. You're going to see that we have daily or monthly data. We're going to click on daily. And there are images and geotiffs and shapefiles. Just take a look at some of the images here. You can take a look at all these images from all these different years. So we can pick, I don't know, 2010 and see what it was like in August. And let's take a look at this PNG. Here you can download it and open it, and you can see here's an image of sea ice. Here's the North Pole up here. So we're looking, our vantage point is looking down on the North Pole, and here's the sea ice extent here. And so what we want to do is actually get for each month, or actually each day, what this extent is, both climatologically, which means on average, what is it like every day, and then we'll be looking at trends in a later video. So let's go back to the parent directory, keep going, and let's go to the actual data. So if you take a look at the data here, there's a couple files that we're going to be using here. One is this Northern Sea Ice Extent Climatology from 1981 to 2010. So this is on average what it's doing. And then later on, we'll be looking at the daily data. So you can download this data. If you click on it, you should see it download right here, the sea ice extent. And you can open it up as a CSV file, and you'll see that there's DOI, or there's day of year, and then you go from 1 all the way down to 366, and that's for leap years. And then you go up back to the top and you see average extent, the standard deviation, the 10th, 25th, 50th percentile, 75th, and 90th percentile. We're going to be looking at the average. So I'm going to go ahead and close this. You do have the option, if you want, to read in a CSV file with R, and we'll be doing that once you download it. But we're going to read this one right off the FTP site. So I'm going to come up here, and I'm just going to right-click on this, and I'm going to copy the link address, just like this, and I'm going to come back over to my code, and I'm just going to put it in a quote, just like that. So this is a site that we're actually going to read data from. We're going to read that directly off of the FTP site, so we're not going to download it to our computer first. So we're going to go ahead and create an object here called arc_CLM. So this is the Arctic Climatology. And we're going to use a function called read.csv. And if you want to know what read.csv is, I'm going to come down here to my console. I'm going to hit question mark, read.csv. Let's go ahead and open that, and that's going to open a help. Here's a description of this function. So read.csv is a version of read.table. Here it is, read.csv. It's going to ask for the file. In this case, our file is living on the internet, so we're going to give it this FTP address, and R will go out there and get it. Does it have a header? In this case, it's true. Our separator is going to be a comma because it's a comma separated. And there's a couple other things in here that we can mess with. And so we're going to go ahead and just use, we'll go back to our read.csv, in our quotes here, I'm going to copy and put this entire FTP path, just like that, okay? So that's going to be our file that's being read in. In fact, I can denote that. I'll just put file equals this. So this is the file that's going to be read in. We are going to say that there's a header equals true. In fact, let's go back and take a look at that file. Okay, let's take a look at this. You can see that there is a header here with these, but there's also one year here that, or one line here that we want to skip because this is not something that we want to read in. We're just going to go ahead and skip that line. And so we'll also add the word skip for the flag equals true. And these can be true. Okay, so if I go ahead and highlight this, and now I run it, you'll see that, I apologize, skip is actually the number of lines that you want to skip. We want to skip the first line. So we'll just go back to that, and we'll run it, and there we go. Okay, so now we have an object called arcclim. It has 366 observations of 8 variables, and if we click on this, you'll see that. Here's the day of year, just like we saw, all the way down to 366. All right, a whole bunch of them down there, and then we have our average extent, which is what we're going to plot, our standard deviation, and all these things. So let's just go over here and let's run a function that's called dim. dim of arc CLM, right? So if I run dim of arc clim, you'll see that it's 366 rows by 8 columns. That's exactly what this is, 366 observations by 8 variables. That's what this is here. And then let's take a look at head of arc clim. This is just another way to view the file. So let's run this, and you'll see here's day of year, average extent. Again, the same thing that we saw when we actually clicked on this object over here. Okay, so let's go ahead and plot only the Arctic sea ice extent. Now this is on average, this is the climatology. So let's put a note in here, and we're going to say we are plotting only the Arctic sea ice extent. Okay, and we're going to use a function called plot. So plot is a very powerful function. You plot x variables with y variables. So in this case, our x is going to be arc clim, and we want a time variable. So that is actually our first column. So if we go back here and we check, we can see our first column is day of year. So that's what we're going to pull out. And in fact, if I just highlight this and type arc clim column 1, you'll see, whoops, just this part, you'll see that those first, this is the day of year that comes out, right? So these are just the days of the year. They're just numbered. It's not in months or weeks or anything like that. This is January 1, and this is December down here on the end. And they're just numbered as calendar days. So that's going to be our x variable. Our y variable is going to be arc clim column 2. Remember, this is the row column denotation in R. Again, if you want to address a row on a column, again, if we look at this again, these are the rows, these are the columns. We're going to plot all rows of the first column versus all rows of the second column. And the way that's denoted is by saying I wanted all the rows, so I put nothing here, comma 1. That's that entire row. And then here's arc clim comma 2, which is that average extent. And again, I'll just pull that out just like that. There's our data that we're going to plot. And so far, so good. So if I actually just put this in here and run a plot, you'll see that we have data. Okay, so we've made a plot right away, which is nice, and we'll take a look to see if we can improve it a little bit. But here's our x value here. The label's not so helpful. It's just arc clim comma 1. The y value is not so helpful, although we know it's sea ice extent, but we can add a couple things to this to make it much more helpful. So the first thing we're going to do is we're going to add a different point character, PCH equals 20. And what that is that these are little open circles. I'm going to make them filled circles, so we'll go ahead and just run that. And you'll see that they're nice and filled now, a little easier to take a look at. And let's add now an X label. Our X lab is, what is the X lab? It's just day of year. That's all it is. So if I run this, all what's going to happen now is day of year is going to show here, and we need to actually change the y-axis as well. So let's go over here to Y lab. This is average extent. This is average extent of sea ice. So let's go ahead and run that. Now we have average extent, and then the last thing we can do that can be helpful is actually put a title on this. Let's go ahead and do main. This is the argument for the main title. This is sea ice extent in millions of kilometers squared. Okay, that's the unit. So let's go ahead and run this entire thing now, and you'll see that we've made this plot much nicer. Oh, it looks like I should maybe add one more parentheses. There we go. There we go. So this is in millions of kilometers squared. So it looks like we go from somewhere about 6 million kilometers here. See, what time of year is this? So this is sort of late fall, this is around, or maybe the beginning of fall, 250. This is about day 250, and then you can see sea ice starts to grow again during northern hemisphere winter. Looks like it reaches a maximum out here somewhere near day 90 or something like that. That's somewhere in March, maybe April, and then starts to melt again. So this is the climatological cycle of northern sea ice. So this is what happens on average on the first day, the second day, the 100th day on average. What does this actually look like? Okay, now let's do something a little bit different. Let's go ahead and read in our Antarctic sea ice extent. And so let's go ahead and just do this. Antclim is now read.csv. Let's go ahead and read.csv. And now we have to find a different FTP site. So what is that going to be? Let's go ahead and go back over to our site here. Let's go back to the parent directory. Parent directory again, all the way up to where it says south. So I'm going to click on south now to go to the southern hemisphere, daily data. I'm going to click on data. In fact, you know what, before we do that, let's go to the parent directory and let's just take a look at some of the images. So let's pick one, maybe 2010. Let's pick August, and let's take a look at sea ice concentration. There it is. Okay, here's a picture of it. So here we have a slightly different situation. We have the continent in the middle. This is the South Pole, so we're looking from the South Pole up back at the Earth. So every direction here is north away. And here's what we call West Antarctica, East Antarctica. Here's the peninsula out here. And here's sea ice surrounding the entire area. So this is a period of high sea ice in the southern hemisphere, but what we really want is to turn that into one number. And so that's why we're going to go back to our CSV files, go back to our parent directory. Let's click on data, and here is the sea ice extent of climatology. And so similar to before, we can just copy this link address, and let's go ahead and just put it in here. I'll put a little quote. That's the one that we're going to be using. I just put it in there just to remind us. And so I'll put file equals, that's where we're going to get it. I want my header to equal true and skip to equal 1, similar to the last file that we ran. So we're going to go ahead and run this thing. Let's run it. Okay, good. Now we have our Arctic climatology, and we can click on that and see what that looks like. Again, here's day of year, average extent, standard deviation, 10th, 25th, 50th percentile. These might be useful to you in the class if you choose to use them, but here's the average extent for each day. So let's go back to our code over here. Okay, so we've got it read in, and now all we need to do, if we want to plot it, is really just kind of copy what we did before here with the Arctic climatology. So I want to plot now the Antarctic climatology, and we can do this because the file structure for these two systems is basically the same. Right? So we know that the Antarctic climatology has the day of year as the first one, right? Very similar. And then our average extent is the second column. And so we'll put Antarctic, this is day of year, here's sea ice extent, and let's plot this now for Antarctic. Okay, we get a pretty different picture here. Now the minimum here is around day 70 or 80, and the maximum is over here now, 275 or something like that. So a pretty different situation. But if we want to compare them, let's go ahead and plot both the Antarctic and Arctic sea ice extent. Let's do that. So I'm going to grab this code here that we already made. So let's go ahead and do that. So that's going to be one that we do first. So I'm going to go ahead and run this again. I'm going to plot my Antarctic sea ice extent. Now I'm going to use a new function called points. And what points does is it adds points to existing plots. So it's not going to make a new plot, but we're going to take our now Arctic data here and put that on top. I'm just going to take these arguments and put them in points. So my X is now my Arctic climatology, my Y, oh yeah, maybe it should be consistent here. Although this doesn't really matter. R is pretty smart. Just denoting what my Y is in each one of these. But that's okay. So my X is my time, my Y is my value here. So again, we can run both of these together now, and you'll see that I get two curves. But they're the same color. So that's not maybe so helpful. So let's go ahead and maybe on this line, let's add color equal gray. So that will add, here's my new plot with my gray line and my Arctic. Here, let's just go ahead and color equal black. That's the default, but we'll just make it explicit. We'll put the black line on, and that's so far so good. But now we have average extent of sea ice, and in fact, why don't we just make this average sea ice extent? I like that better. It's always nice to have them as descriptive of legends as, or descriptive as axes as you can, so that the reader knows what you're plotting. So we have average sea ice extent, we have day of year. Here's our sea ice extent in millions of kilometers squared. In fact, you could put the units over here too if you wanted to. You would just adjust this column over here to do that. But what we need now is a legend, because we got two curves on here, and a reader won't know which the Arctic and which one is the Antarctic, so we can use a function called legend. So, in fact, let me just come down here, type legend, and you'll see that legend is a great way to add a legend to a plot. And there's a ton of different handles in here. I'm not going to go through all of them on this video, but there is an X and a Y where you want the legend to be. And we'll just go ahead and take a look, use the ones that are useful for this particular plot. So legend, we want our X, where do we want it? We're going to use a text descriptor instead. We want it on the bottom right. So it's going to be down here, okay? What's the next thing that we need? Well, we need to actually describe what the legend is. So legend is going to be, we're going to concatenate, just like we did in some previous videos, two names, the Arctic, comma, and the Antarctic. Okay, so if we run this, you'll see that we just have two names, Arctic and Antarctic, but we have to say which one is black and which one is gray. So the next thing we need to do is to add a point character. So our point character is 20 for both of these plots, and our color, so we'll do Arctic first. So let's concatenate two together. Black, two colors, and gray. Arctic is going to have the black, Antarctic is going to have the gray, and let's go ahead and run that. In fact, if I just run this like this, yeah, okay, so there's black and there's gray. Well, we don't have a line through it. Maybe we should do that. Let's add a line. So let's do this. LWD, line weight equals 2. Run this whole thing again. You can see we have a little line here. And now we've got this kind of funky box around this, and so I'm going to add another flag here, BTY. That's box type. It's just going to be no box type, lowercase n. And again, if I just run the legend, it's just going to slap another legend right on top of the old legend. So if you want to start with a new plot to see what it looks like, you have to copy it all the way up here to the new plot. There it is. And the last thing I want to do is maybe make this look a little bit nicer. I'm going to put another flag in here called horiz. Horiz, logical if true, sets the legend horizontally rather than vertically. So let's do true, and you'll see that the whole plot now, now we have Arctic and Antarctic, so we have a nice sea ice extent. Okay, so what do we see here? We see that, well, sea ice is high and low at different times of year depending on the season, right? So in early days, day 0, so this is, or day 1, this is January, you can see that the Arctic has fairly high sea ice, the Antarctic has decreasing sea ice. That's because it's winter time up here in the Arctic, moving into summertime here in the Antarctic, and you can see that these two patterns actually oscillate with each other, right? So when one is high, the other one's low, and when one is low, the other one is high, and that's the seasonal effect. So seasons are different in the northern and the southern hemisphere. So when we have our summers in the northern hemisphere, the southern hemisphere has its winters. So one interesting thing that we could ask is to see whether or not these two actually cancel each other out. So I'm just going to grab this plot here again. So I'm going to add just a thing. Let's go ahead and plot the addition of sea ice between the Arctic and the Antarctic. So we'll see whether or not these actually cancel each other out. So let's copy this. We're going to start with our plot command, and that's what's really nice about this, is that you can just copy and paste code that you already had, right? So our X is going to be our Antarctic Clim 1, which is just our day of year. It's the same day of year between these two objects. And Antarctic Clim 2, that is the extent of the Antarctic, but we're just going to add plus here and put arc Clim 2, and we're going to add these two together. So I'm going to take my Antarctic column 2 and add it to the Arctic column 2, and we're going to plot them together just like that. So let's go ahead and make this black, maybe a little easier to see, and let's go ahead and plot this. Okay, so here's the average sea ice extent now for the whole globe. If you add those two together, and what's really interesting is they don't exactly cancel each other out. There are times of the year when there's like a minimum sea ice cover for the globe, and that's not mirrored later on in the season. And in fact, over here near day 300, right? So maybe about 2 months before the end of the year, you know, we have maximum extent here. So it's a pretty big range. So that's kind of interesting that the Arctic and the Antarctic don't cancel each other out in terms of sea ice area coverage. And that's something to think about when you're thinking about trends in these systems. Oh, and one last thing, that you want to make sure that you save your work here. So you can save the code here, and you can call it whatever it is that you want, and save it maybe on your desktop somewhere. You know, this is, you know, sea ice code or something like that, that you know what it is. And then also, with any of these plots, we can scroll back through these plots and you can export them. So you can save it as an image, you can copy it to your clipboard and then paste it into a Word document, save it as a PDF. If you copy to your clipboard, which is the most popular thing to do, you can just hit copy plot and it's copied, and then you can paste it into a Word document or a Google Doc or something like that that you're working on.